Hello students, today we are going to learn about applied physics lab experiment Fermi energy. The aim of the experiment is to understand temperature dependence of resistance of a metal to obtain Fermi energy. What all we require for this? We require a copper coil, heating bath, thermometer, voltmeter, ammeter and power supply. Okay, so this is your copper coil on the wooden stand here. This copper coil is attached with two wires, and this is the water bath, and this is the Fermi energy kit, which contains the ammeter, voltmeter and the current source. The required circuit diagram is like this. For this, we go with the connection as A to a wire from A to A, the wire from X to X, wire from Y to Y, and P to P and Q to Q. The coil has to be connected here. Okay, in this, go to the last page, that is this page, and note down the Fermi energy, the readings for Fermi energy of metal and for the error analysis. Note down the current at the room temperature. For this, we need to switch on our instrument. This is the first button we are switching, and this is the one more power supply button which is here. We are going to switch it on. Now this is your current reading, this is the voltage reading. Note down the current reading here in milliamperes and the voltage in millivolts. After this, switch off this device and remove the connection from the coil. Lift your coil along with the wooden stand here and keep it in the water bath, which is being heated. Now heat your copper coil up till the temperature of 90 degrees. You have the thermometer attached here. Till 90 degrees, go on heating this. So this is the red line which will show the 90 degrees. So after the 90 degrees of temperature, once it reaches 90 degrees, lift the coil from the water bath and keep it on the stand, and immediately attach this to the kit. Your instrument should be ready. Now the temperature goes on reducing. For example, we note down the first reading for temperature as 85 degrees. Note down the corresponding current reading and the voltage reading. After 85, take it to the 80, then 75, 70, then 65, 60, 55, 50, 45, 40. Correspondingly, note down the current values and also note down the voltage values. After this, note down calculate the resistance using V divided by I. For example, this is 46.3 and our current is 22.3 something. Now divide voltage by current, that is V divided by I, and note down the value here. This is somewhere 0.253. Note it down for the 3 decimal value. Similarly, as you go on reducing the temperature, note down the current value, note down the voltage value and calculate the resistance value in each case. Now convert this temperature to the Kelvin, that is 85 plus 273. Here 80 plus 273 and so on. So you get the readings. Okay, once the readings are over, switch off your instrument. Now go for the calculations. The reference temperature for all the readings is 45 degrees centigrade, and corresponding temperature in Kelvin is 273 plus 45. Resistance for this, for 45 degrees, whatever resistance you get correspondingly here, that value of resistance you need to note down. Now plot the graph of taking temperature and resistance. Temperature should be along x-axis, resistance should be along y-axis, which is a straight line. Find out the slope using this formula, that is AB divided by BC, delta R divided by delta T. This slope is a very small value of order of 10 raised to minus 3. Note down this value, and by using this equation we are going to calculate the Fermi energy. Here we have the C into T by R the whole square into slope square. C is already given to you, slope you have found from the graph, and T is the reference temperature which we have noted here. R is the reference resistance. So you get the Fermi value in terms of joules. Convert it into electron volts. This is a very small value of somewhere 7 electron volt. Okay. And also we are going to calculate the Fermi energy theoretically. Already you have noted the current at room temperature here, voltage at room temperature here, mobility of the electrons is given to you, then length of the copper wire what we have used is given to you, radius of the copper wire is given to you. Find out the electron density using this equation. Then Fermi energy is given by the formula h square divided by 8 pi square m 3 pi square n 2 raised to 3, 2 by 3. You get this value in joules converted to electron volt. Okay, to calculate the error, now the error in the measurement of current is delta I, that is 0.1 milliampere. Error in the measurement of voltage is this. Find out the error in the measurement of density of the electron, then find out the error in the measurement of Fermi energy. So you are going to get the answer for the error here. This is the theoretical value of the Fermi energy, and this is the experimental value for the Fermi energy. Thank you.